Welcome to Ask and Learn.
In this question, we have a homemade capacitor, and it is done by placing two 9-inch pie pins. So we have two of them, each is 9 inch, and 5 centimeters apart. And then we connect them to terminals of a 9-volt battery. So that is the setup. First, capacitance. Part B is a charge on each plate. Part C, electric field halfway between the plates, E halfway. And then part D is the work battery to charge plates. And then finally, we want to say if electric is inserted, which of these above values will change. So let's work on them one by one. So these are a lot of questions, but it's nice that once we find one of them, we can find all of the following questions. So let's look at part A. Here we're just using some of the definitions of capacitance is epsilon naught times area over distance. So here is pi r squared, and r is 4.5 inch. So epsilon naught is 8.85 times 10 to the negative 12 squared times 10 times meter squared. Okay, and pi r, and unfortunately I have to convert things into SI unit because we are inches here. So 1 inch is 2.54 centimeter, which is 0.1 meter. 1 inch. So this whole thing squared the area, and now we have 5 centimeter, which is 0 meter, and together it's us 7.265 times 10 to the negative 12 farad, which is roughly 7 picofarad. Okay. Now if we already know capacitance, it's not times the charge. Charge is times potential difference. Potential difference is 9 volt. So we have 7.267 times 10 to the negative 12 farad times 9 volt. So times 9 volt equals 6.54 times 10 to the negative 11. So roughly 65 picocoulomb. Okay, now the electric field. The electric field, I mean, it says halfway, but it really is almost uniform, to be honest. So because for capacitance, you're supposed to have a uniform electric field, except unless you are very close to the edge, which we are not really considering that situation over here. So E, it's voltage over distance. So that is 5 volt 0.05 meter, which is 180 volt per meter. That is electric. Okay. Finally, we have to work out the work by the battery. Okay. So in order to do that, we also have this. Maybe we should use the letter U. The formula that is 1/2 of CV, and we know what V is. So we're just plugging the numbers. And it's 2.9 times 10 to the negative joules. And you can into 3 if you want to. At the very last, we have to figure out if we insert some dielectric material into it, what is going to change. Okay, so firstly, if we insert some dielectric material into this thing, obviously we can tell that the capacitance is going to change. So if this is, then of course this epsilon naught will have like an extra factor kit. So C change, capacitance changes. If capacitance changes, the charge will change because the voltage doesn't change in the capacitance. What about the energy? Not energy. What about the electric field? The electric field doesn't change because as long as you're in the air, it doesn't change because you have the same voltage difference, you have the same difference, so it's still the same. But the work done will change because distance changes, so U also changes. So 3 things will change. This changes, this, but the electric stays the same.